component of this lecture is looking at, again, how to do a mixed model ANOVA SPSS. And finally, we're going to wrap up on how do you actually look at interactions, specifically the post hoc or simple main effect test when you have a situation where you actually have a mixed model. Now again, if it's a between subjects, we actually have our standard ways of calculating simple main effects, and that's actually the syntax that we use. If it is an all within subject design, in other words, it's a cross design where everyone is exposed to each level, you actually have to basically do a priori ANOVA to look at those differences. With a mixed model design, there's a couple of possible ways that we can look at this, and we also have to recognize that we may be needing to look at it in different ways because we have a mixed design. We have both between subject and within subject variables. So we're going to start with just again how to do this in SPSS, and it's going to look very similar to doing simply the crossed or within model design, and that is we're going to start at general linear model repeated measures in SPSS. So once again, we're going to have our repeated measures and we have to define it. We're still having to define the within subject factors. We have to name it, we have to list the number of actual levels, and we also have to name the measure, or the DV, what we're actually naming the outcome. So again, we label our IV, we list the number of levels, we hit add, we label our DV, and again, we hit add. Once we've done that, we click define. Now this is where we vary. With the repeated measures design, at this point, all we're doing is bringing over the actual columns that represent the various levels of our within subject design, and we're still going to be doing that. So we select each level of the within repeated IV, and we click it over into the within subjects variable. What we're changing is we also now have a between subjects design, or between subjects IV that we need to add in as well. And it's right here in this box. We select that independent IV, the IV that's between subjects, and we click it over to the between subjects factor. At this point, we're going to go through basically the same process we did before with the repeated measures. We're going to hit plots, and from plots, we're going to basically tell it how to plot out what we're actually seeing. And the plot basically gives us a visual representation of an interaction if it's there. So again, we have two factors at this point, birth order and time, one of them a between subject design, one of them within subject design. And we're going to bring those over and click add to make sure that we're getting a visual representation of the actual interaction if there is one. At that point, we're then going to come back to this screen. We're once again going to hit options. When we're in the options screen, we're again going to be bringing over everything we want to display means for. We're also going to be collecting, again, descriptive statistics, estimate of effect size, and the homogeneity tests. Once again, we're going to click continue. And at this point, we're ready to click OK. And now we're going to walk through what we actually get as far as the output from SPSS. So the first thing, again, we're going to get is a mixed model ANOVA SPSS output. We're going to be getting basically the first column is self-esteem pre-test, self-esteem post-test, and self-esteem follow-up. That would be our first variable. And then the second one is birth order. So firstborn, middle child, lastborn, only child. So birth order is our between subjects design in this particular example. You can't be firstborn and middleborn. And self-esteem pre-test, post-test, and follow-up would be what everyone's subjected to, the within subject design. And again, we're going to be getting our various means. Now, I do want you to note the small n here. This represents the total number of participants that went through your study in any form. We actually need this for later when we're looking at post hoc tests. So just kind of put that in your back pocket as we move forward. We're going to get some SPSS assumptions. Once again, we're going to get that Mauchly's test of sphericity. And again, at this test, we're basically wanting to see that to be insignificant. We're wanting it to not be significant. So we're looking good here. And we're also going to get the Levene's test of equity of error variance for each one of our actual outcomes, pre-test, post-test, and follow-up. I'm sorry, our IV. And again, we're looking for them to not be significant, insignificant. And again, in this case, we have 0.56, 0.16, and we have 0.03. But remember, I told you on Levene's test that honestly, we can go ahead and we're probably good to go as long as it's not significant at the 0.01 level. So at this point, though we're a little marginal, we can move forward with our assumptions. So we're going to get a test of within subjects effects. So we're going to get our time by birth order, which is an interaction, and our error. So notice that our main effect of birth order is not in this particular one. we actually have, this is our within subjects effect. So we have our degrees of freedom, both for time and the interaction, and our degrees of freedom error. We have our F's, we have our significance, and we have our partial edge squared. But what we do not have in this table is the between subjects effects. And again, we're going to have our MS error. And again, this green box is to remind us that we're going to need that later for a Tukey's test looking at a mixed metal design to find out what are the least common differences that we can claim are significant in an interaction. So again, we're just putting that aside because we're going to use that in an equation later. We are also going to get the test for between subjects effects. So this is basically the main effect of that IV that's between subjects. And again, we're going to get our degrees of freedom, error, we're going to get our F, we're going to get our significance, we're going to get our partial edge squared. Just recognize that one of those main effects, the main effects for the between subjects design, is in a separate, basically a separate table in the output for SPSS. We're also going to get multiple comparisons of basically looking at self-esteem by Tukey's HSD, so honestly significant difference test. So this is looking at the differences within that between subjects design. So this is basically what we're looking at, the way we'd always look at any kind of actual between subjects design if we're needing to do post hoc tests. So we have firstborn, whether it's different than middleborn, lastborn, only child, middle child, whether it's different, lastborn, whether it's different, and only child, whether it's different. For the simple main effects, we're actually going to have to calculate a side equation, and that's what I've been telling you to put a few things aside, and that's Tukey's HSD for a mixed model design. In this case, the equation is Q. Q is a standardized number. It's 3.37. We put the mean squares that we put aside earlier into the top of the equation. We put the n in the bottom of the equation, and this is going to tell us, again, the honestly significant difference that we would have to find between two means for us to be able to claim that there is a difference between those groups. So again, in this case, we get an HSD of 0.434. Any mean difference greater than that is significant. So simple main effects tests, generally speaking at this point, depending on the complexity of our design, we may need to run additional tests. And again, Tukey's equation is based on the smallest n, so we may actually want to look at this differently. This is another way to maybe consider this as kind of an a priori situation. So K is the number of treatments or cells. So generally speaking, the more cells we need to test, the more questionable or the less precise Tukey's equation is going to be. What we may want to do is run between subjects ANOVAs for each level of the within subject factor with post hoc tests if there's more than 2 levels. And run a repeated measures ANOVA for each level of the between subject factors with post hoc tests, again, if there's more level. So the idea here is we're going to isolate each level of the between subjects design and then look to see are there differences between the groups. So let's say, for example, that factor 2, A and B, is our between subjects design. We would isolate only people that were in factor 2A, so only in the first condition of our between subjects design, at which point we run an ANOVA for the within subject design. Is there differences there? And if there are, we run the post hoc test. Where are those differences? And this is a way we can kind of parse out and look for the differences in simple main effects. Now, in order to do that, we're going to have to isolate the variable, the between subjects variable, before we run each analysis. So how do we isolate variables in SPSS? We go down again to data, all the way down to select cases. We click on that. Once we're there, we're going to click on if condition is satisfied. Once we've selected this, we're going to get to this screen, at which point we're going to have to basically just write an equation. So let's say we were wanting to split our groups. We wanting to isolate variables based on gender. So in this particular case, let's assume gender only has 2 levels, male or female. What we're wanting to do is run a unique ANOVA on the differences on our within subject design on specifically gender male only. So, or female only. If male was coded as 1, we could then write an equation gender less than 2. That's going to tell it that basically I only want to look at variables that are gender less than 2. If we were wanting to look at the other way, we might put gender greater than 2 or greater than 1 to get the people that are 2s. You could also simply put gender equals 1 or gender equal 2. The equation is basically just identifying to SPSS which group out of this particular variable you're wanting to look at. And to do that, again, we'd select the variable that we're wanting to split the data on. We'd bring it over to the equation and we'd write an equation, equals, greater than, less than, whatever makes sense for what you're actually specifically looking for. Now, obviously, if you have 4 or 5 conditions in that one categorical IV that's between subjects, you may actually be using the equal sign, but you may also just simply looking for, how about these 3 groups against these 2 groups? Again, it completely depends on what you're wanting to look at. Once we've actually identified that, we're going to click Continue. And once we're back on this stage, all we're going to do is click OK. And if we go to the variable view, we're going to see that there are these strike-through lines. These are the people or the individuals in our study that are no longer going to be included in any analysis. So in this case, if you look at gender 1, the genders 1, men, are still in and still available. Anyone that had a gender of 2 is no longer being looked at for any analysis. So this would then allow us to now run additional tests just on women. Once we were done with those additional tests, we would then switch over and select an isolated variable to be at women only, so 2s, at which point we again could then run that analysis. So again, most of today's lecture is really more practical. We've already kind of dealt with most of the theory of factorial ANOVA. This is more of how do we operate within SPSS to look at these in different ways. And another way to think of these lectures is, in this case, these really are just a precursor to get you thinking about these ideas prior to applying them and working with them as problems in the lab section for this week. So definitely let me know if you have any questions. Like I said, these are more kind of a primer for what you're going to be doing in lab, because that's mainly what we're focusing on this week. How do you actually practically use these various tools when the tools themselves, mixed models and repeated models, are fairly difficult to begin with? And really, it just takes a little bit of practice and time to kind of conceptualize what you're doing and how you're doing it when you're actually entering these variables and these models into SPSS.